All right, we are just going to solve one of the most trickiest problem in the syllabus on statistics. Tricky in the sense it's not that difficult, but we need to pay attention, and that's in the concept of standard deviation and CV, coefficient of variation. And this is a kind of a continuation series on the previous parts, and this particular episode is an extension of Part 5A, which I put in the previous episode. So let's check out that or the other parts before you come to this. And specifically, we are discussing the type 3 variety of problems on variance, standard deviation, and CV. And within that, we are talking about one specific variation where we are trying to find the standard deviation and the CV for group data. So this is the variation that we're talking about. And in that variation, in the last two episodes, or last episode, we solved this problem, and we solved this one over here, which is kind of repeated. This one, and this one. See, all are repeated here. The numbers are same. So now we are going to talk about the one that is left over. We are saving this the best for the last, the summer 2019 problem. These are just appeared once. And usually all these problems come for 6 marks. So it's a huge weightage. So just pay attention, okay? So this particular kind of a variation, this is not a different variation, the same thing, but there is a trick to this problem on how you read this, okay? In which I missed it few times. So let's talk about this problem, okay? So I'm going to rewrite this problem over here at the bottom. And this is what we have solved earlier, so skip those things. Okay, so this is what we're talking about. I've highlighted in red. Most trickiest problem needs fine attention. So what is that we need to find? We need to find the standard deviation, SD, and CV for the following table. And we have been given marks, students and marks. So as good as this is the class interval and this is the frequency, okay? But they're given in kind of an example. That's a good thing. So it's easy to relate when we talk about a real example. But if you see the words, it says marks below. Okay, that means marks below. That means how do I read this? Marks below. If you see this, the one that I highlighted here, marks below. I've highlighted this in red. Okay, that's you need to pay careful attention. It's very hard to easy to miss it because you might start solving the problem, and that's the reason I say it's very tricky on how you interpret the meaning of this. And for interpreting the meaning of this, you need to find first ensure that you read the question properly. That's rather than just spend the time on what they're asking. Okay, this could be hidden meaning. Like I said, this has come only once, but it's better you keep attention on this one. So the way we need to understand this problem is, on the surface of it, there is no class interval and all those things. It looks like a straight ungrouped data frequency where we think that 6 students have got 5 marks, 16 students have got 10 marks and stuff like that. So we can think about that way. But when you focus the attention on marks below, then the whole meaning changes, okay? And how do I interpret this, okay? So let's focus on this one first. So the way I interpret this, 6 students have got marks below 5. So if the minimum mark is 0, so 6 students have got marks below, 6 students have got marks between 0 to 5 and less than 5. So they could have got 0, they could have got 1, they could have got 2, they could have got 3, they could have got 4, but not 5. So anyway, between this range. So it is as good as the marks. If you take the marks for this range is going to be definitely less than 5, not equal to 5. But the marks could be equal to or greater than 0. So that could be the range. That's how we read this, okay? And that's pretty simple. That's the whole concept of group data. So although this whole problem looks like ungrouped data or just a group frequency where there is no class interval, but because of this wordings and this verbiage of marks below, we'll see that this becomes a group data with a class interval, okay? We'll see that. Okay, that's step number 1. Then if you go to the next interval, then we say, how do we read this? And let's try to read this part the same way we read the first part. That means 16 students have got marks below 10. So now we have got 16 students who have got marks below 10, okay? So that does not include 10. 10 is not included, but anything less than 10. But how far we go? Anything less than 10 could be all the way through 0. And this thing, right? So here the section could be 0. They can get 0 or equal to 0 marks or less than 10. But this particular class interval is already a part of that. That means we are already counting that in this first interval. That means we already counted the 6 students have got marks less than 5. And again, we cannot count that 16 students have got marks less than 10, because if some student have got mark 1, let's say 1, we cannot count this student twice, because the student will be already covered here. If the student has got 1 mark over here, then the student will be already covered in this interval of 0 to 5, right? He will be one of these 6 students. So we cannot count this 6 or any part of this 6 students again in the next interval. So that means we have to separate that out, and that's a trick. So paying the attention on this word verbiage below, marks below, what does it mean, which will help you define the class interval. Like this will be like 0 to 5, this will be like 5 to 10, this will be like 10 to 15 and stuff like that. That's one. And the number of students also we need to recalculate, because we cannot count the same set of students twice, and that's what it means. Okay, so if you see here, this part of number of students, which we kind of think about frequency, this is a combined frequency. And what does it mean? Let me erase it over here. This is a combined frequency. And what does it mean? This 16, if this is the frequency of students, this 16 also includes this 6. This 6 is a part of this 16. Similarly, this 16 is a part of this 28. This 28 is a part of this 38. So this is a combined frequency. So we need to separate out the frequency so that we exactly know how many students have scored marks below 5 in this class interval, and how many students have scored marks in the class interval of 5 to 10. It's not going to be 16. We have to subtract this from this. Similarly, we have to subtract this from this. Similarly, we have to subtract this from this, and we have to subtract this from this, because we cannot double dip the frequency. That's what it means. And if you see here, I've subtracted the first frequency. So in essence, if you ask me how many students have got marks in the range 5 to 10, that means they could have got 5 or equal to 5 marks. It could be 5 or equal to 5, but definitely less than 10. Okay, so that's not 16. That is only 10 students, because we are removing this 6 students from this 16, because they already counted in this first interval. And that's what I wanted to highlight. So whatever I've written in red, that's what you need to focus on. And that's the trick on this problem. There are 2 tricks. One, what is circled, marks below. If you focus on this, based on this, you will have to define this as a class interval, meaning that you have to convert the problem that looks like ungrouped into group format. That's the first trick. Okay, and because of this very wordings, this number of students, the frequency also need to recalculate. We will drop the combined or the overlapping frequency. We need to drop this, and we need to calculate the actual frequency, which is not appearing over here, which is by subtracting that. That's what we need to calculate, and that's the trick. And based on that, if you see, I put the table here. So I put the class interval. I'm defining the class interval based on the marks below. So 0 to 5, 5 to 10, whatever I kind of explained here. I'm putting the class interval, and I also return the combined overlapping frequency that is given to us as it is 6, 16, 28, 38, and 46. I've not made any changes here. I've just copied the number of students as frequency, and I'm calculating my changes over here. So the way I'm going to read this is, okay, this 16 students also include this 6 students. So I'm going to separate that out. For the first interval, there is nothing in the preceding line. So the first will be as it is, no change here, no change. But this 16 includes this 6, because it's a combined frequency. So I'm going to separate this 6 from the 16, which will give me 10. This 28 also includes this 16. Okay. So I'm going to separate this 16 from 28, which will give me this. Similarly, this 38 includes this 28. This 46 includes this 38. So I'm going to recreate those actual frequency, not the combined one. And I'm going to use this whole section as my frequency of students for this class intervals. So I made, before even starting the problem, I made 2 major adjustments of getting the class intervals from the problem and getting the actual frequency based on the words marks below. So this 2 words, this 1 word below has created all this circus over here. So just want to make sure that you do not forget that. And once you get that, the rest of the things is easy. So my given problem is going to be like this. I've got this class interval, which is the marks, and I've got the frequency of the students, which is this column. So assume that I've got this column, this first one and this second one. And this, based on this, I need to find whatever they have been asking, which is standard deviation and coefficient of variance. They are not asking mean, but anyway we have to find the mean. So we'll take this two new derived columns as a starting point and we'll calculate that. And these two new derived columns are over here, if you see here. Okay, in the gray, whatever highlighted, this is the new derived column. I've just copied it here. If you see 6, 10, 12, 10, 8 is my frequency. So 6, 10, 12, 10, 8 is my frequency. And rest is simple. We just follow the same steps that I explained in the previous episode, or if you see here, all the steps will be the same on how to calculate that data. So let's calculate that data. And how do we go? The first thing is I need to find the mean, because I'm going to follow the rule of M, V, S and then CV. So first I need to find the mean, which is over here. For finding the mean for group data, I need to calculate the midpoint, which I put in asterisk as a reminder that is important, and I've highlighted in red, midpoint of class interval, which is nothing but the midpoint of this. So what is that we are assuming? So we are assuming that 6 students on an average have got 2.5 marks. We don't know exactly what they have got. They could have got anywhere between 0 and less than 5. 0 and equal to 0 and definitely less than 5, we do not know. So we are giving the benefit of doubt. Let's assume that we'll take the average of this, the midpoint of this, and we'll assume that these 6 students have got 2.5 mark. Similarly, the midpoint of 5 and 10 is 7.5, and we'll assume that 10 students, which is my new frequency, on an average for this class interval have got 7.5 marks on average. That's what I'm assuming. So these marks are for individual per student on an average. But I've got more frequency, more than one student, and hence I need to multiply these two columns, which is what F into X is. So this is the X part and this is the F part. So I'm multiplying this so that I get the total average marks for the whole class of 46. If I add up all the frequency for all the students, this one and this one and this one and this one, my sigma F, total number of students in the class is 46, and the total marks on an average scored by all of them based on this rule is 595. And if I take the ratio of this over this, 595 over 46, I'm going to get the mean. If you see my mean, which is the X bar, 595, the summation, and 46 is the total number of students in the class, I'm going to get a value of 12.934. And what it means is, for all the class put together, what it implies is for all the class of 46 put together, I'm not really worried about who got how many marks, but my calculation says on an average, we can assume that each of these 46 students, every single of this 46 student on an average has scored 12.93 marks. That's what it kind of implies. That's what it says. And that's what it's called as average or arithmetic mean or X bar. Now, since we need to find the standard deviation, for that we need to find the individual deviation. And whenever we talk about individual deviation, think about the number line, like I always give that example, right? It's a distance or number line. So if this is my 0, my average is say 12.5. This is my 12.5, 12.93 number, right? So I want to know on an average, how far is the student's score from this score? So for example, my first midpoint is 2.5. So let's say this is my 2.5, okay? So if one student scores 2.5, on an average, the mean deviation, the individual deviation of this person's score, this student's score from this is the difference between this and this. So whatever is 2.5 minus 12.5, that means this on a number line, this student is this much distance, whatever the difference from this point, and which is nothing but minus 10.434. And this we're talking about one student. So we are saying that the individual student on this class interval, out of these 6 students, every single student is roughly minus 10.43 distance away from the mean. That's his individual deviation. And likewise, we calculate for all the class intervals, the deviations. Just do a difference of x minus x bar, where x is the midpoint and x bar is the same value, 12.93 for all of the rows. And like we anticipated, some of these values on individual deviations will be negative, which is, we don't want that. And we know that one way to get rid of the negative value is take the square. So we have a difference. We are going to square the average difference of this. So that's what we are trying to do here. And once we square it, we are going to get the positive value of each of the squared difference. So this is the difference and this is the square difference. We are going to get the positive value for each one of them. And we know that this mean deviation is for one student. There's one student. We calculate it for one student, like I explained over here also in the number line. This is for just one student. But we have got more students in the class interval. So this one student's deviation is this much, and this one student's square deviation is this much. But we need to find the square deviation for all the students in this class interval, which is going to be 6. Let me get rid of this so that you can clearly see it. So let me repeat it again. So this is the deviation for one student. This is how far he is from the mean deviation, he or she. And this is the square difference to make it positive for one student. But I've got 6 students in this class interval. So I'm going to multiply this 6 by the square difference of 108 to get this value. If you see here, the square difference multiplied by the frequency of that class interval. So put together, this is going to be the square difference for all the 6 students in terms of the average deviation for this class interval 653. And like that, I'm going to find for all of it, where I'm going to multiply each row by the respective frequency to get the square difference for all the students in that interval. And then I'm going to be one step closer to find my variance. Okay, now variance I know is going to be the square difference for all the students divided by the total number of students. So what do I have? I have the square difference here, and I need the summation of that. I'm going to sum this up. So basically I'm going to sum this, and this to get this value, 1891 point, whatever it is. The total students is frequency is 46. I know that. I'm going to take the ratio of this over this to get my variance. If you see here, 18.91 divided by 46 is equal to 41.115. That's my variance. That is my sigma square based on this formula. And I know that once I get my variance, I can get my standard deviation by simply taking the square root of this, which is what I'm going to do here. Standard deviation is equal to sigma square, where I take the square root of this variance, which is 41.115, and the value I get is 6.412. And since it's in green, that's my final answer. So the answer to this question is, for standard deviation, the first part is we need to find the CV also, but for the standard deviation, the answer is 6.412. And like I explained, these 2 steps is very important, where we need to multiply the frequency. We normally forget that, so I put an asterisk in red color. So whenever you get the deviations or the square deviation, do not forget for group data to multiply it by the number of students in that class interval. Otherwise, you will be just calculating for a single student and the answer will be wrong. So this is the most important step after the midpoint step. Okay. So for group data, always remember this step, that there's one step that you cannot forget. And once you get the 6.414, we can easily find the CV. We have the 6.14412, and the CV is going to be a ratio of standard deviation over mean, which is sigma over x bar. This is x bar. So we have sigma over x bar. Sigma, we know that it's 6.412, and mean we have calculated over here in the orange color, the x bar 12.934, and we take that and we multiply by 100 because we need the unit in percentage. So the ratio of this into 100 will give us close to 50%, that is 49.57%, and that's your second part of the answer where they're asking the CV. So that's how we calculate the group data for standard deviation, and the only trick is this part in red that I explained. Do not forget that, and pay attention before you solve the problem to these tricky words marks below and what it means, where you will have to make some adjustments to both the rows in terms of class intervals and kind of split the frequencies to find the actual number of students. So that's kind of what I wanted to bring it to attention in this episode. That's why I kept it separate. So hopefully this was clear. And in summary, these are important problems. This whole variation between this episode and the previous, this comes for 6 marks. Okay, you will definitely get one problem for 6 marks. There is no doubt about it. The problems are very easy, but do not do calculation mistakes because there are too many numbers and you might get confused. Remember the MVS strategy: find the mean always first, and the variance and the standard deviation. A lot of textbooks kind of write the formula for standard deviation and try to find it out, but don't go with that because you will have to remember the formulas and you will mess it up. So keep it simple. Find the mean, square the difference. If it's group frequency, multiply by the frequency, and then find the standard deviation by taking the square root of sigma. and be extra careful for group data step because you need to find the midpoint and multiply by the frequency, which is what I told. And also watch for twisted words like marks below or marks above and stuff like that, which will help you define the class interval also, and also kind of change the frequency, because you should not count the frequency to more than once for the students, because that will create confusion. So that's a wrap up on this episode, the final episode on statistics. Hopefully this was helpful, and this will help you secure 6 marks, and it's a very important chapter. Like I said, 18 to 19 marks, so don't miss it. And this variations type 3 itself comes for at least 12 to 15 marks, and sometimes it comes for 18 marks also. So keep focused on that one. Super important chapter, cannot miss it in the order. So good luck, and I'll see you in different topics.